So we are starting with the second part of the chapter, that is the rate as a measure. Okay, or rate of change we can say. So the change, if anything is changing, increasing or decreasing, okay, if anything is changing, it indicates we have to use derivatives, because derivatives is nothing but the studies of change. It's a study of change. Okay, so if anything is changing, we have to use derivative. Okay, that is the concept in this particular exercise. Fine. Now let us go to the first problem, exercise 11C. Exercise 11C, question number 1. Now y square is equal to 4x. This is a equation given to us. And if you're reading the problem, find the rate at which y is changing with respect to x when x is equal to 4. Now, first of all, this is given. Y square is equal to 4x. This is given in the problem, right? It's a parabolic curve. You did not know that, but then still I'm saying it's a parabolic curve. Okay, now y is changing. Y changes. It's given in the problem. Y is changing. It is very well given in the problem. Y is changing with respect to x. The meaning of this particular statement is y is changing because x is changing. Because x is changing. Okay, y changes because x changes. So we need to find out how y changes with respect to x when x is equal to 4. So find the rate at which y is changing with respect to x. Meaning of that line is y is changing with respect to x. So since y is changing with respect to x, we will differentiate both the sides with respect to x. Why with respect to x? Because the value y is changing with respect to x. It's given in the problem. Differentiation of the given equation with respect to x meaning is taking derivative on both the sides. D by dx of y square, d by dx of 4x. Okay. Now the derivative of the right hand side you all very well know, that is 4 into 1, which is equal to 4. And the derivative of the left hand side, you'll compare this with x raised to n formula. Okay, this is x raised to n formula. So it is n into x raised to n minus 1 into d by dx of anyone. Can you tell me what is a part of this round bracket? You know this topic. Can you put it over the chat box? This particular value where I put a question mark. Yes, guys, can you just tell me? Hello, hello, hello. Yes, correct. So I got some answers over here. That's why. That y is due to the chain rule. Okay, I hope you all remember differentiation derivatives, because x is getting replaced with y. X gets replaced with y. Fine. So 2y dy by dx is equal to 4. I'll write it on the next slide. 2y dy by dx is equal to 4. Okay. So dy by dx is equal to 4 upon 2y. Dy by dx is equal to 4 upon 2y, right? I'll show you the previous slide. See, for the given equation, I'm differentiating with respect to x. Okay, now this is a easy task for you. Calculation of derivatives. Left hand side chain rule, right hand side 4 into 1, which is equal to 4. So 2y dy by dx is equal to 4. So dy by dx is equal to 4 upon 2y. Okay, now see, I'll just write a working note over here. Okay, y square is equal to 4x. Now when x is equal to 4, they have given x ka value as 4, right? The value of x is 4, they have given in the problem. So y square is equal to 4 into 4. So y square is equal to 16. Therefore y is equal to plus or minus 4. Y is equal to plus or minus 4. And these are fair steps. So whatever I've written in the right hand side, those are fair steps. Okay, just copy till here. Okay, now can someone figure out what is should be the next thing that is supposed to be done? We'll put the value of y in equation number 1. Okay, right? So on the next page, I'm going to put y equal to, there are two cases now. Case 1, put y equal to 4 in equation number 1. So dy by dx is equal to 4 upon 2y. So y is 4. So this is equal to half. Okay, and case 2, put y equal to minus 4 in equation number 1. Dy by dx is equal to 4 upon 2 into minus 4. So this is equal to minus half, because 4 upon minus 4, this 4 upon minus 4 will give you minus 1, right? Okay, so we got our final answer. The rate at which y is changing with respect to x. The meaning of that statement is dy by dx. The rate at which y is changing with respect to x. So it can be half or it can be negative half. So rate may increase or decrease. That is the concept over here. Just share your feedback whether you have understood this problem or not. If you can just let me know over the chat box. Yeah. So now see, I'll be solving question number 2 right now. Question number 2. Okay. So I'll just read the problem for you. If the radius of a circle increases from 3 to 3.01 centimeter, find the increase in the area. Okay. How the area is increasing. Okay, now initially the radius was 3 centimeter. It got increased to 3.01 centimeters. Okay, so the radius increased, right? So don't you feel if the radius is increased, the area will also increase? If the radius of the circle increases, don't you feel the area also will increase of the circle? Yes or no? Just let me know, please. Okay, so now see, we need to find out the increase in the area. See, they are asking in the question, the last line, find the increase in the area, right? Now, first of all, I'll make you write what is the change in the radius. Okay, how the radius changes over a period of time. So the time is supposed to be a very crucial variable over here. So I'll just write down dr by dt. Okay, where r is the radius and t is the time. Dr by dt. How the radius is changing. So the radius changes from 3 to 3.01, right? So it's an increment. Increment by how much? Can someone tell me? Increment by how much? We are calculating the change in radius with respect to time over a period of time. Initially it was 3, now it is 3.01. So what is increment or change in radius with respect to time? How much is it changing? By how much? Yes, correct. Some people are giving the correct answer. So it is changing by 0.01. Okay. Okay. It can be centimeter per second, centimeter per minute. Unit of time is not mentioned in this problem. So let us not put any unit in this particular value. So initially it was 3, then it changes to 3.01. So how the radius is changing? Radius is changing by 0.01. How 0.01? 3.01 minus 3. Okay, so the change in radius is 0.01. So this is the very important point in the problem. Guys, have you understood this or you are confused? Any feedback? Okay, now we need to find out the increase in the area. Increase, when they say increase or decrease, it is nothing but change in the area. So the change in the area is nothing but dA by dt. They are not asking area, but then they are asking change in the area, how the area is changing, how the area is increasing. Okay, over a period of time. We are taking time as a variable over here because the change will happen over a period of time. Okay, so now A is equal to pi r square. All of you know this. So this is my starting point, area of a circle. Differentiating with respect to time on both sides. Now this time we are not differentiating with respect to x. X is not the variable. We are taking the variable as time. Everything is changing as per time. Okay. So d by dt of A is equal to d by dt of pi r square. D by dt of A is equal to d by dt of pi r square. Fine. Have you copied till here? Now d by dt of A. D by dt of A is nothing but dA by dt. A is not a constant. A is changing. Now area is changing. So d by dt of A is not 0. Okay. Yeah. Please copy. Please copy this. Then right hand side derivative. I'll take pi outside and put it before d by dt. And this I'm doing because pi is a constant. Do you all know that pi is a constant? Yes, pi value will not change. If it is not changing, then it is a constant, right? So I'll take this pi outside into d by dt of r square. Pi outside d by dt of r square. Okay. So dA by dt is equal to pi derivative of r square. Now r square is not a constant. R is not a constant. R is changing. Radius is changing. Okay. So can someone tell me what is the derivative of r square with respect to t? Okay. So it is 2r x raised to n formula. But then the variable is not x, the variable is r. D by dt of anyone? D by dt of r, correct. D by dt of r. Okay. Because when we compare this with t raised to n, the main variable is t, not x. Okay. So what is t getting replaced with? T is getting replaced with r. Okay. Now see, we have all the values on the right hand side. Pi will remain pi, 2 will remain 2. Radius, this is the initial radius. So the initial radius is 3. The initial radius is 3. It's given in the problem. Initial radius is 3. And dr by dt. Do we have this value dr by dt? Yes, we have calculated on the previous slide. Dr by dt. See, 0.01. Okay, it's not 3.01, it is 0.01. Fine. So this will be 0.06 pi. The final answer will be 0.06 pi units. Now it can be centimeter per second, centimeter per minute, centimeter per hour, whatever it is. That time unit is not mentioned in the problem. Hence, I'm just writing units. Okay. Any feedback? Have you understood this problem? Your feedback will help me. Yes. If you just give me a feedback, it will be better for me. Others, can you tell me? Okay. Yes, units we will discuss it later in classroom also. Yeah, it has to be square units, correct. But then we don't know what exactly this thing is. Centimeter square plus second, centimeter square plus minute per minute, or centimeter square per hour. We cannot really comment. Okay, it will be square, correct. But then since it is area, na, that's why. Yeah. Let us go to the third problem. I'm erasing this. I'll go to the third problem. Question number 3. The height of a right circular cylinder is 5 centimeter and it remains constant. Okay. So now see, I'm just drawing this diagram for your reference. Okay. So this is a right circular cylinder. Fine. This is the radius. This is the height. What will remain constant? Radius or height? Reading the first line, can you tell me what will remain constant, fixed? The height will remain constant. See, we are not assuming this. They are giving this in our problem. They are mentioning this thing in our problem. We are certainly not assuming this. See, sometimes they may say radius will remain constant. Sometimes they may say height is remaining constant. Okay. You have to be very clear in the understanding of the problem. The cylinder is closed from both the ends. The radius of the base is decreasing at a constant rate of 0.04 centimeter per second. So this radius which I have shown over here, this radius is decreasing. It's decreasing. It's shrinking at a constant rate of 0.04 centimeter per second. Okay. Now what is decrease? Decrease is nothing but change. Something increases or something decreases. It's nothing but change. So what is changing? The radius is changing. So dr by dt is equal to minus 0.04 centimeter per second. Can someone tell me why have I used the minus sign? Why have I used the minus sign? Yes, minus indicates decrease. Okay, right? Find the rate at which total surface area is decreasing when the radius is 2 centimeters. Read the next line very clearly. Find the rate at which total surface area is decreasing when the radius is 2 centimeters. So the initial radius is 2 centimeters. Radius is decreasing. Okay, but then height is fixed. Height is not going to decrease. And due to change in this radius, due to decrease in the radius, the total surface area is also decreasing. Okay. And we need to find out how the total surface area is decreasing. At what rate? How it is changing the total surface area. Okay. Now this much amount of information is given to us. We'll try to solve it further. Total surface area. Okay, A is equal to 2 pi r square plus 2 pi r square plus 2 pi r h. This is the total surface area of the cylinder which is closed on both the sides. Now, why 2 pi r square? Because top and bottom we are having circles. So these two circles are having area of pi r square. So it will be 2 pi r square because there are two circles. And curved surface area. The curved surface area. The curved surface area. Okay, is 2 pi r h. Okay. You need to remember this formula. Fine. So this is the total surface area. Now we need to find out how the total surface area is decreasing, how it is decreasing. That we need to find out. Now the total surface area decreases with respect to time. Okay. The radius is changing with respect to time. The radius is decreasing with respect to time. So the total surface area also decreases with respect to time. But then there are certain constants over here in this particular equation. I'll mark those constants. 2 pi is a constant. 2 pi is a constant. Any more constant is there in this problem, in this particular equation, which you can tell me? Anything more which is constant, which you feel like it is a constant? Yes, h is a constant. They have mentioned h is a constant. We are not assuming, they are mentioning to us that h is a constant. Okay, so remember these things. These are constants. Now we'll differentiate with respect to time on both sides because everything changes with respect to time. So dy dt of a is equal to dy dt of 2 pi r square plus 2 pi rh. So dA by dt, individual derivative, dy dt of 2 pi r square plus dy dt of 2 pi rh. Okay. So 2 pi being a constant will go outside and 2 pi h in the second derivative. Okay, this derivative, second part of the derivative, 2 pi h will go outside because 2 pi h, all three terms are constants. Okay. Please copy this. I'll wait for you. Should I proceed? Okay, so I'll go to the next slide now. dA by dt is equal to 2 pi dy dt of r square plus 2 pi h dy dt of r. So dA by dt is equal to 2 pi into 2r dy dt of anyone? Dy dt of, please tell me. R, correct. Plus 2 pi h dr by dt. So dA by dt is equal to 4 pi r dr by dt plus 2 pi h dr by dt. Okay. Now, if you observe, we are having each and every value over here. Each and every value we have. Okay, you can keep pi as pi itself. No need to put 22 by 7 or 3.142. I think, yes. They are saying take pi as 3.142. Okay. And we are having r, initial value of r, that is equal to 2, initial value of h, that is equal to 5. And dr by dt, we know what is dr by dt. Dr by dt is minus 0.04. Okay, we'll put all these values in this. Okay. So next page, dA by dt is equal to 4 pi r. R is nothing but 2, initial radius. R is the initial radius. Okay. Dr by dt minus 0.04 plus 2 pi h is 5, dr by dt minus 0.04. Okay, this values I am putting. Fine. So dA by dt is equal to 4 into 2, that is 8, 8 into 4, 32, minus 0.32 pi. Okay, and this is 10, 10 into 0.04 is minus 0.4 pi. So this is equal to dA by dt is equal to minus 0.72 pi. Now put the value of pi, 3.142. They're asking us to put the value of pi is 3.142. If they're not asking, you can keep it in pi. So 0.72 into 3.142, 2.26224. So dA by dt is equal to negative 2.26224. Okay. Now here we can place the units because we know the units for time as well as uh, radius. So it is centimeter square per second. Centimeter square. Why square? Because it's area. Okay. Fine. You can round it up to 2 decimal digits. That's not a problem. Okay. But then it was getting terminated at 26224. So I kept this entire number. Okay. Guys, I'm waiting for your feedback on this problem. Are you able to understand? Yes, everyone. If you can just respond. Yeah. Question number 4. Question number 4, if you can just read for yourself. Okay. A balloon contains certain mass of gas whose volume is V centimeter cube. So the volume is V and whose pressure is P Newton per centimeter per square centimeter. Okay. And it is known that P and V obey the law. PV is equal to 1000. So PV is equal to some constant. That constant is 1000. And this is given to us. Pressure and volume. P is pressure and V is the volume. If the volume increases at a rate of 50 centimeter per minute, find the rate of change of pressure when the volume is 40. Okay, now the initial volume is 40. This is also given to us. Initial volume is 40. If the volume increases at the rate of 50 centimeter per minute, so there is change in volume. There is change in volume. It's given in the problem. Why I'm saying change? Because the volume is increasing. See, increase or decrease is nothing but change. The volume increases at a rate of 50 centimeter per minute. So dV by dt, volume is changing with respect to time, is 50 centimeter per minute. 50 centimeter per minute. Okay, right? Now this is also given to us, right? I hope you are reading the problem very clearly. Okay, so what are they asking? Find the rate of change of pressure. So the pressure is also changing because volume is changing. So they're asking dP by dt when the volume is 40, when the initial volume is 40. Have you understood the nature of the problem? PV is equal to 1000 is given. Initial volume is 40. Volume is changing. They are mentioning in the problem. Volume increases at a rate of 50 centimeter per minute. So volume is changing with respect to time. So dV by dt is equal to 50 centimeter per minute given. And they're asking find the rate of change of pressure. Pressure also changes with respect to time because volume changes. So dP by dt. Okay. Next slide. Now PV is equal to 1000. You can also start derivating here itself. Otherwise, you can take V on the other side. So you'll take V on the other side. P is equal to pressure is equal to 1000 upon V. Now differentiating with respect to time on both sides. Differentiating with respect to time on both sides. So d by dt of P is equal to d by dt of 1000 upon V. Okay. Don't take the variable as X. If you're taking X as the variable, then X should be time. Fine. So you can do that also, but then I'm taking the variable as T. Time represents T, or time is denoted by T. So d by dt of P is nothing but dP by dt. Okay, dP by dt. And here 1000 will go outside. 1000 into d by dt of 1 upon V. 1000 being a constant, it went outside. 1000 into 1 upon V. D by dt of 1 upon V. So dP by dt is equal to 1000. I'll compare this with 1 upon x formula. 1 upon x as in 1 upon t, because the main variable is not x, it's t. So 1 upon t, the derivative of 1 upon t is minus 1 upon t square. So the derivative of 1 upon v will be minus 1 upon v square. T is getting replaced with v. So d by dt of v, that is the chain rule. Don't forget the chain rule part. Okay. So dp by dt minus 1000 upon v cube dv by dt. Now we have all these values. We know the value of initial volume. We know this value. We know dv by dt. This value also is given in the problem. Right? We'll put those values. Okay. So minus 1000 upon v cube. V is nothing but 40. 40 cube dv by dt. dv by dt is nothing but 50. See, it's given 50. Okay. So you can calculate this further. You have a calculator, you can certainly calculate this. Right? So can you tell me what is the answer? Yeah, V square. I'm sorry. I'm sorry. It's V square. It's not cube. 1000 into 50 upon 40 square. That is 1600. 31.25. So dp by dt is negative 31.25. Fine. So dp by dt is negative 31.25. Now the unit of pressure is given over there. Newton per square centimeter. Newton per centimeter square per second. It's with respect to time, right? dt is also there. Pressure with respect to time. So minus 31.25 Newton per centimeter square per minute, not second. I'm sorry. It's per minute because the time is measured in terms of minutes in this particular problem. Okay, so minus 31.25 Newton per centimeter square per minute. Okay, so there are quite a few questions in this particular exercise. We are going to go very slow with this, right? And complete the exercise. So this was session number 1 on this particular exercise, that is exercise 11C. Thank you.